Hello everyone, I hope your exam season is going well. We're going to be going through the 2016. I did upload onto our OWL site two of the past finals, the 2015, 2016. 2015 has some written solutions already up, but I thought I'd do some video solutions because a couple people have mentioned that they find that a bit more helpful. So just like with the midterm, I'm going to be going I think it was the 2016 mid, or was it the 2017? One of the midterms. I did videos like this, and it was every 4. I think it was the 2016 because it was all multiple choice. So I'll be doing 4 questions per video. Feel free to bounce around where you want to. So let's start with questions 1 through 4. Alright, so question number 1. The graph of the function y equals f of x is obtained from the graph y equals 2 to the x by first shifting up 1 unit and then reflecting the resulting graph in the x-axis, which of the following is a formula for f of x. Okay, so this is not really calculus. This is more, do you remember functions from grade 11 or grade 12? But shifting up, so I would start with my given function, and then to shift up, you just add 1, just like shifting down by 1 unit would be subtracting 1. Shifting to the left, for example, would be x plus 1 inside, so you'd add 1 to the x value rather than outside with the y's. So there we've shifted up 1, and then we need to reflect in the x-axis, which means we need to, what might look like this now needs to look like this, and the way we do that is we just slap a minus sign in front of everything. And I haven't taken a look at the answers, so we might expand it out like that. What have we got here? So that matches with E there. Alright. Good. Alright, 2. If the tangent line to the graph of y equals 3 to the x minus c has a slope ln 27 when x is equal to 3, the value of c is. Okay. So we know how tangent lines and slopes are related, so we might want to take the derivative. So the derivative of 3 to the x would be 3 to the, and then times ln 3. And now our inside function is x minus c, and then we need to do times the derivative of x minus c, so that would just be 1. So the derivative of our curve, or the slopes of our tangents, are just going to be 3 to the x minus c ln 3. Now we're told when x is equal to 3 that this is ln 3. Or sorry, that this is ln 27. So we'll have 3 to the 3 minus c ln 3. Okay. What are we going to do from there? Well, I noticed that 27 is 3 to the 3. So I could rewrite this, bring the exponent out front. And we could divide by ln 3 on both sides. So now 3 has to be the same as 3 to the 3 minus c. The only way that's going to work is if 3 minus c is equal to 1. C has got to be equal to 2. Alright, question 3. If the limit as x approaches 2 of f of x over x minus 2 squared is pi by 2, then the limit as x approaches 2 of f of x over x minus 2 is. Okay. So in order for this to work, what have we got here? Well, if we just sort of plugged in, we'd get f of 2 over 2 minus 2 squared. And so that's something over 0, and yet somehow that's equal to pi by 2 in the limit. That doesn't quite make sense unless this was sort of a L'Hopital's rule 0 over 0 situation. And if that's the case, then that tells me f of 2 must be 0. Okay. So where can we go from there? Well, what do we need? What do we know? So we know f of 2 is 0. We want almost the same thing. We want the limit as x approaches 2 of f of x over x minus 2. Again, plugging in, you'd have f of 2 over 2 minus 2, which would be 0 over 0. Okay, so it could be almost any value. Now this pi by 2 here is kind of interesting. But what could we do? Where could we go from here? Well, we might try actually trying to work something out with L'Hopital's rule. That's certainly a possibility. What else could we do here? I'm trying to think of the best way to handle this question or explain it. My gut reaction says the answer should be A, 0. Just because I have so little information available. But, what can we do? Well, I suppose we could try to do L'Hopital's rule here. So then, if I did L'Hopital's rule, the derivative of the top would be f prime of x. And the derivative of the bottom would be 1. So, if I just knew what the limit as x approaches 2 of f prime of x was, I'd be all set. Is there a way to know that? Well, again, if we go back over here and realize that this is a 0 over 0 L'Hopital's rule, how do we eventually actually get down to pi by 2? So we realize f at 2 has to be 0. So if we did L'Hopital's rule, we'd get f prime of x. And then we'd get a 2 would come down, we'd have x minus 2 here. And when I plug in there, I'd get that f prime at 2 over 0. Again, you're going to eventually get a limit of pi by 2. So f prime at 2, or rather the limit of f prime at 2, should be 0. So, yeah, gut reaction of A works out. Alright, and now 4, to wrap up this particular video. So this is sort of a nice little squeeze theorem style question. I can see that right away because I've got some less than or equal signs. So I know a function f of x, and the only thing I know about it is sandwiched between these two functions near minus 5, and we're asked for the limit, minus 5. So, well, we just need to check what's the limit as x tends to minus 5 of 2x plus 2. Well, that'd be negative 10 plus 2, so that'd be negative 8. How about so x squared plus 12x plus 27. X squared, so that'd be 25 minus 5 times 12, so that'd be minus 60 plus 27, and that'd be 52 minus 60, also negative 8. And so since the smaller one and the bigger one are both heading to the same place near x minus 5, then f of x is squeezed in between them and is forced to go to minus 8 as well. Alright. So we're off to a great start. The 2016 one, I believe, I'll just quickly double check, has 48 questions. Multiple of 4 there. Yes, 48. So that's one video down. We've got 11 more to go. And as I say, feel free to bounce around and take a look at questions that you want to go through. Okay. So I will see you in the next video for more of our final exam. 2016.